you ever think of buying good quality meat at unbeatable price, think Magilac Butchers, your only suitable solution for quality meat for you and your family consumption. Our comprehensive range of meat products include minced meat, beef slices, top side, knuckle, rump steak, silver side, tenderloin, strip loin, and forequarter. We offer consistent value, quality, and service through animals grass-fed and bred, especially for their meat. This makes meat much more tasty, succulent, tender, and easy to cook. All meats at Magilac Butchers are halal, including for the first time in the Gambia, the new Mongolian whole lamb, available only at Magilac Butchers. Rush now and visit Magilac Butchers on Caraba Avenue, opposite the Petrogas petrol station traffic lights. For inquiries and orders, please call 7688-688. That is 7688-688. Magilac Butchers, the home of quality meat and chicken products at unbeatable prices.
Hello viewers and listeners, welcome yet again to another math lesson for the upper basic level. And as usual, before we go on to today's lesson, we are going to go over the assignment that I gave you the last time. I gave you two questions to try. Number one was find the complements of 50 degrees, 20 degrees, 55 degrees, and 45 degrees. And number two was find the supplements of 142 degrees, 105 degrees, and 95 degrees. Now we start with the number one. Number one, we are looking for complements, and we know complementary angles add up to 180. Sorry, they add up to 90 degrees rather. Okay, complementary angles add up to 90 degrees. So if in A, one of the angles is 50, we assume the other angle is x because we don't know its value. And we know if we add those two angles, we should get 90 degrees. So we can simply say x plus 50 is equals to 90 degrees. And from there, we just undo the 50. So subtract 50 from both sides. And then the 50s will cancel each other out from the left-hand side. So you get x as 90 minus 50 should give us 40 degrees. So the complement of 50 degrees is 40 degrees. You move on to the B and do the same thing. This time you are given an angle of 20. The second angle is not given, so we assume it to be y. Again, they are complementary. So if you add them, you get 90 degrees. Then, again, solve this by undoing the 20. So you subtract 20 from both sides of the equation. The 20s will cancel each other out from the left-hand side, and therefore you have y being equals to 90 minus 20 should give us 70. So this complement of 20 degrees is 70 degrees. Then letter C, you are given an angle of 55 degrees. The complement we don't know, so we can use m to represent it. Again, if we know if you add the two of them, we should get 90 as our sum. So that means m plus 55 is equal to 90 degrees. Subtract 55 from both sides of the equation. The 55s will cancel each other out. Then you have m as 90 minus 55 should give us 35 degrees. So therefore, the supplement of 55 is 35 degrees. And then finally, D, you are given an angle of 45 degrees. The complement we don't know, so we can use a variable to represent it. Let's say P. And again, we know P plus 45 is equals to 90 degrees, okay? And if you subtract 45 from both sides, that gives you the 45's cancel each other out. P is 95, no, 90 minus 45 should give us 45 degrees. So therefore the complement of 45 degrees is 45 degrees because 45 plus 45 is 90. Number 2, we are looking for supplements from the word supplementary. And we know that supplementary angles add up to 180 degrees. So if in the first part we are given an angle of 142 degrees and we are asked to find its supplement, which we don't know, we can use x to represent it. We know if we add the 2, we should get 180. So that's simply going to give you x plus 142 is equals to 180. Then you subtract 142 from both sides of the equation. And the 142's will cancel each other out. You have x now being equal to, if you subtract 142 from 180, that should give us 38 degrees. So therefore the supplement of 142 degrees is 38 degrees. Then the B part, you are given an angle of 105 degrees. You are asked to find its supplement, which we don't know, so we can use y to represent it. Again, we know y plus 105 should give us 180 because they are supplementary. You subtract 105 from both sides of the equation. And this 105 will cancel each other out, and you are left with y equals to, if you subtract 105 from 180, that should give us 75 degrees. So therefore, the supplement of 105 degrees is 75 degrees. And then finally we go to the C, and C, you are given an angle of 95 degrees. The supplement is not given. Again, we can choose x to represent it if you want. And we know if you add the two of them, we should get 180 degrees. So that means x plus 95 is equals to 180 degrees. Subtract 95 from both sides of the equation. This 95 will cancel each other out. We have x as, if you subtract 95 from 180, that should give us 85 degrees. So the supplement of 95 degrees is the angle 85 degrees. Now, that was the correction to our assignment. Then we move on to our lesson for today. And as you can see clearly on the screen, we are looking at, or we are starting from parallel lines. Okay, so parallel lines. Say parallel lines are lines that move in the same direction without ever meeting. That means they are lines that move in the same direction, but they would never meet. The lines do not meet because they maintain the same distance apart. That is why the lines never get to meet, because they move in the same direction, but then they maintain the same distance apart. So they can keep going on forever, but they would never meet, all right? Like if you stand at one point and your friend stands a few meters away from you, if both of you maintain that distance between you and you move in the same direction, you will never get to meet, all right? So you'll be moving in parallel lines. So parallel lines are lines that move in the same direction, but they never meet. They never meet because they maintain the same distance apart. Now, of course, what you see on the screen are just examples of parallel lines you have there. which means they can either be horizontal, they can be vertical, or they can be slanting, all right? But what is important there is that they move in the same direction and they maintain the same distance apart, so therefore they never get to meet. Like you can see the first one, the horizontal lines there, AB and CD are parallel because they're moving in the same direction, but they will never get to meet. Likewise, the second one, the vertical lines, they are still moving in the same direction, that is X, W, and Y, Z. They move in the same direction, but they never get to meet. So they are also parallel. And then you see the other ones that are slanting, P, Q, and RS. Those two are also parallel. Why? Because they're moving in the same direction and they are maintaining the same distance apart, so they never get to meet. So those are also parallel. You know, you cannot just see lines and assume they are parallel. Like if I just drew lines like this. Now, that alone is not enough information for you to say that these two lines are parallel. You need more information than just this. Either you have arrows to indicate that they are moving in the same direction. That indicates they are parallel. You need that. Or in the absence of these arrows, then some labeling needs to be done. If this is A is put here, B is put here, C is put here, and then C. So you have line AB and line CD. Still, you need to have something like this. You read this as AB is parallel to CD. All right? So you must have either the arrows to indicate it or something like this. The lines are labeled and then you are told that AB or whatever letters are parallel to each other. Otherwise, you cannot assume that any lines are parallel. Then we look at what a transversal is. A transversal is a line that cuts across parallel lines. A transversal is a line that cuts across parallel lines. So whenever you have parallel lines, any line that cuts across them is called a transversal. Like you can see on the screen there, you have line AB and CD being parallel, and then line PQ is cutting across them. So that line PQ there is a transversal. Okay? Now this is important. Whenever a transversal cuts across two parallel lines, 8 angles are formed. When a transversal cuts across two parallel lines, you will always have 8 angles being formed. Now we are going to need this. Angles are formed whenever two straight lines meet. So if you look at here very carefully, this is a straight line and that is a straight line and they meet here, so therefore an angle is formed there. 1. Okay? Also, if you look at this is a straight line, that is another straight line and they meet here, another angle is formed there, so you get that as 2. Likewise, if you take this straight line and this other straight line, they meet at a point, so they form another angle there. That gives you the third angle. And then this other straight line and this straight line, they also meet, they form another angle, and that gives you your fourth angle. So you have 4 angles up there. Now when you come down here again, you have this straight line, they meet, they form an angle. That becomes our, okay, let's make it this way. Let's say the straight line meeting with the straight line, of course they do form an angle here, which we call our 5th angle, okay? And then you have this straight line, also with this straight line they meet at a point here, they form another angle at that point. That's our 6th angle. And then this straight line and this straight line, they also meet, so therefore they form an angle there. And that is our 7th angle. And then this straight line and the straight line, they also meet, so they form an angle there, and that gives you our 8th angle. So clearly you can see that whenever a transversal cuts across two parallel lines, 8 angles are formed. Now let's group these 8 angles. If you look at the diagram very carefully, between the two parallel lines, there are 4 angles there, all right? Like angle 3, 4, and 5, 6 are the angles that are found between the two parallel lines. And we are going to call those angles that are found between the parallel lines as our inside angles, all right? So angle 3, angle 4, angle 5, and angle 6 are our inside angles. That's important. We are going to need that later on. And then the other angles now that are not between the two parallel lines are our outside angles. So angle 1, angle 2, angle 7, and angle 8 are outside angles. So therefore it means we have 4 inside angles. We also have 4 outside angles. The inside angles are the angles that are found between the two parallel lines, okay? That is going to be useful to us. Right. What you can see on your screen is alternate angles, okay? Alternate angles. You see, these are 2 inside angles that are on opposite sides of the transversal. These are 2 inside angles that are on opposite sides of the transversal. And what I have there is an easy way of remembering what they are. Inside, inside, opposite sides. Which means both angles are inside, but they are on opposite sides of the transversal. Now if you go back to our diagram, you can clearly see here, if we take angle 3 for example, it is an inside angle. All right? Also, if you take angle 5, that is also an inside angle. But are they on the same side of the transversal? No, they are not. So therefore, we can say angle 3 and angle 5 are alternate because they are both inside and they are also not on the same side of the transversal, which means they are on opposite sides of the transversal. So they are alternate. Now, apart from 3 and 5, can you identify any other angles that are also alternate here? 2 inside angles that are on opposite sides of the transversal. Now, clearly, we can see that angle 4 and angle 6 are alternate. They are both inside and they are on opposite sides of the transversal. Now, that was just an illustration there, that angle 3 and angle 5 are definitely alternate. Now, there's a key important message there. It says alternate angles are equal in measure. All right? So alternate angles are always equal, which means whatever value is here is also going to be here. So if here is 30 degrees, for example, then here also will be 30 degrees. All right? If this angle here is 150 degrees, then this angle here is also 150 degrees. So it's important to note that alternate angles are always equal. That's why we say there angle 3 is equal to angle 5. Now, if you observe carefully, the alternate angles are always formed in what looks like a Z or a letter Z, like you like to call it. Look here very carefully. If this and this line are parallel, that's the condition that they have to be parallel, and that is your transversal, all right? This angle here and this angle here are alternate. And what does this look like? It looks like a Z, a letter Z. So alternate angles are always found in what looks like a letter Z, all right? And of course, this can be rotated anyhow, because I could have turned it this way. It is going to look like this. If this line is parallel to this line, then this angle and this angle here also will be alternate. So most times, if you can look at a letter Z in your diagram, the angles inside that letter Z will be your alternate angles. Okay. So moving along, we look at what we call corresponding angles. Now, this is when you have one inside angle and one outside angle that are on the same side of the transversal. All right? This time, one of the angles is inside, the other is outside, but they are on the same side of the transversal. That gives you corresponding angles. All right? If you look back to your diagram, if you take angle 6, for example, it is definitely an inside angle. Also, if you take angle 2, it is an outside angle. But are they on the same side of the transversal? Yes, they are. So therefore, they are corresponding. Right? One is inside, the other is outside, and they are on the same side of the transversal. So therefore, they are corresponding angles. That was just an illustration. You see there that angle 2 and angle 6 rather, and angle 2 are corresponding. Again, it's important to note that corresponding angles are always equal. So just like the alternate angles, corresponding angles also are equal. So if you know one, you have found the value for the other one because they are equal. Now let's try something. Apart from angle 6 and angle 2, can we find any other angles here that are also corresponding? Now if you look closely, you will see that angle 5 and angle 1, angle 5 is inside, angle 5 is outside, but they are on the same side. So therefore, they are corresponding and also equal. Again, if you look closely, angle 4 is inside, angle 8 is outside, and they are on the same side of the transversal. So they too are corresponding and also equal. The same happens with angle 3 is an inside angle, angle 7 is an outside angle, and they are on the same side of the transversal. So therefore, they are corresponding angles and they are also equal. If you observe clearly, look at angle 3 and angle 5, and follow my hand and tell me what letter do you see. I have this. That's a line. And I do this. Does that not look like an F? Yeah. So the corresponding angles are inside the F. And the F, of course, can be torn in different directions, but you still have the F. Then we move on to co-interior angles. Say these are two inside angles that are on the same side of the transversal. These are two inside angles that are on the same side of the transversal. So you can simply say inside, inside, same side. They are both inside and they are also on the same side. We call them co-interior angles. That is an example we have there. Angle 3 and angle 6. If you look at them closely, you can see that angle 3 is inside, angle 6 is also inside, and also they are on the same side of the transversal. So therefore, they are co-interior. Now, apart from angle 3 and angle 6, which other angles can you identify here as being co-interior? Clearly, we can see angle 4 and angle 5, they are both inside and they are also on the same side of the transversal. So therefore, they are co-interior. Now note that co-interior angles are supplementary. Remember, we have dealt with supplementary angles. We know they are angles that add up to 180 degrees. So co-interior angles, unlike our previous angles, are not equal. They add up to 180 degrees. So in this case, if you add angle 3 and angle 6, your answer should be equal to 180 degrees. So always, if you know one of the angles, of course, you can easily find the other one because you know their sum is 180. So if you know one, just subtract that from 180 to get the other one. Okay? And what letter do you think you can find these co-interior angles in? If you look at this, if you follow my hand, and this angle, they seem to be inside a U that is turned to face on the east. All right? Of course, if you have had it in this form also, it comes to look like an N. If this line and this line are parallel, therefore this would be co-interior to that angle. Okay? So co-interior angles are not equal. Instead, they are supplementary, which means they add up to 180 degrees. And then we have what we call the vertically opposite angles. Vertically opposite angles. When two straight lines intersect, that means when two straight lines meet each other or they cross each other, the two angles opposite the meeting point. And remember, the point where two lines meet is called the vertex, all right? So the point or the angles opposite the vertex are called vertically opposite angles, all right? Now let's see an example. If you have this straight line and you have this other straight line, you can clearly see they meet at this point. So that's their meeting point, and that is their vertex. So the angles opposite that vertex, like you know, there's an angle here, and there's also another angle here. And those two angles are opposite each other. So we call them vertically opposite angles. All right? Likewise, if you look at this other angle here, and this angle right here, they are also opposite each other. They are opposite this, and they are at the same point, and they are opposite each other. So therefore, they are also vertically opposite. All right? Now, if you go back to our diagram, can we identify which angles here are vertically opposite? And you can easily see 1 and 3 will be vertically opposite. 2 and 4 would be vertically opposite. 5 and 7 would be vertically opposite. And 6 and 8 also would be vertically opposite. All right? And what do you observe? What does it look like? You have a line, you have another line, they cross. That definitely looks like a letter X. All right? So you use the letter X to identify vertically opposite angles. Again, that is just an illustration. You can see there angle A and angle B are vertically opposite. Likewise, angle C and angle D are also vertically opposite. And note that vertically opposite angles are equal, which means angle A is equal to angle B and angle C is also equal to angle D. Why? Because they are vertically opposite. Right, so we have a diagram here, and it says in the figure above, list down 16 pairs of corresponding angles. All right? We have a diagram, and we are asked to list down 16 pairs of corresponding angles. Let's have the diagram here. Makes it easier. So it is from this diagram that we are supposed to list down 16 pairs of corresponding angles. Now that should not scare you. The number 16 appears big, but then I'm sure we can definitely get them from here. First, we know with corresponding angles is one of the angles is inside, the other is outside, but they are on the same side of the transversal. So to make life easy for yourself here, you can first focus on the vertical parallel lines and get all your corresponding angles from there, and then come and focus on the horizontal parallel lines, and then you will get the rest of your corresponding angles. Now, if we focus on the vertical parallel lines, then therefore this AB and CD, the horizontal parallel lines, will now serve as transversals because they are cutting across the vertical parallel lines. So in that case, which angles are inside? Angle C, angle L, angle F, and angle M are inside angles, all right? Because they are found between these two parallel lines. Actually, we are focusing on the horizontal parallel lines, all right? So those four angles are found between the two horizontal parallel lines. So those are the inside angles. And then AB, IJ, HG, P, and O are the outside angles. So now we can start to list. What's our first pair? We are looking for an inside angle and an outside angle that are on the same side. And then I can see E is inside, A is outside. So A and E are corresponding because one is inside and the other is outside, but they are on the same side. So I can say A and E. That's one pair. So we have 15 more pairs to go. Number 2, if you just move to the next angle, angle F is inside, angle B is outside, but they are on the same side. So therefore, they also are corresponding. So I can have B and F. Angle 3, or number 3, so you have got 2 pairs, 14 more to go. Now let's start from up here now. This angle D is an inside angle. Angle H is an outside angle. And they are on the same side. So they also are corresponding. So we can say D and H. So we've got 3 pairs now. We go to number 4. Again, if you now take C is an inside angle, G is an outside angle, and they are on the same sides, so they two are corresponding. So you get C and G. Number 5, of course, we are done with here because you cannot get any other angles that are corresponding here. So let's move to the other side. There also, if you look closely, M is inside, I is outside, and they are on the same side of the transversal. So M and I are corresponding. Likewise, N is inside, J is outside, but they are on the same side, so they also are corresponding. So number 6 will be J and N. So you have got 6 pairs. Then continuing to the 7th, take angle L is inside, angle P is outside, and they are on the same side. So they also are corresponding. So L and P are corresponding. angle 8, or pair 8 rather. Angle K is inside, angle O is outside, but they are on the same side, so they two are corresponding. K and O corresponding. Right, we are halfway there. We have got 8 and we are looking for 16. If we now look at vertically, using those two parallel lines, you will see between these two parallel lines, you have angle CL, F and M still inside, and JK, NO, DE outside. So we can use those again to get our remaining sets of corresponding angles. Like if you take angle C is inside, angle K is outside, but they are on the same side. So therefore, C and K are also corresponding. Number 10, if you come down here, angle F is inside, angle N is outside, they are on the same side, so they two are corresponding. F and N corresponding. Then we move along. Still, if you go back to this L, it's inside, D is outside, but they are on the same side, so they also are corresponding. So we can say number 11, D and L. Number 12, if we check, M is inside, M is inside rather, E is outside, and they are on the same side, so they also are corresponding. So you can say M and E. Okay? Now we go to number 13. We are still looking for more. What we can find also is if you take angle, we have got DL already. Let's avoid repetition. We have got DL. We have got E and M. Yes. We have got F and N. Yeah. We have got C and K. We have got C and K somewhere. Okay, let's see what's missing. We have got 4 more to go. Now, also, if we take angle G very carefully, it's an inside angle, and we check angle O outside, and they are on the same side, so they also are corresponding G and O. Okay? Then still, you take angle P, it's an inside angle. Angle H is also, is an outside angle, but they are on the same side. All right? So therefore, they also are corresponding. So you can say 14, that is angle H and angle P. H and P. So now we are at number 14. If you keep going, number 15, if we take angle I up here, is inside, angle A is outside, but they are on the same side of the transversal, so they also are corresponding. So we can say A and I. That leaves us with only one angle now, all right? And if you look very carefully, angle B is inside, angle J is outside, but they are on the same side of the transversal, so they also are corresponding. So that is angle B and angle J. There. And we were asked to list 16 pairs of corresponding angles, and we have been able to do just that. Okay? And with that, we come to the end of today's lesson. I hope you have been learning something from the lesson. Till we meet again, goodbye.
nkana mobula kuma coronavirus mu jankari leti mun ka mol kurandi kabo toto mesenla kata fo niji kuran la ala nyin jankar la bon e bota mun kalama e ka fole covid-19 ning se nyin jankaro kele fon damban lese bete ya nyofe coronavirus ma mobo dulalong imu kelti fo imu musulti imu mofinneti fo mu mo koyleti wala imu nyin sikari leti woto nabo nya nsem fonyo fatam fanso la alin chodiro fatam fanso nin chodiro satinna molmu yanyin kuran la tama sero soto kadung tamala la esila tama sero mabo janning ibita bundalla mun se ma koyno kanyin kuran jara nabo nya nyin sentel beke kuran nyina bundala ni aju be karala molu mulkatu tama silo kan kata doku wala karan walla ibe dunne badiul kan nyile nafa bale soto na banko lodulala wolodula kilin yole soto ka covid-19 kele woto nse fatam fanso nin toku ya bay sakarantuma nyin tamala la karola nse mfanjube nga mol makoy mul sulata makoy rola nga sai nga fo nyoyen kam bulol ku wato wati nga karan nya dalma ndal nyal wala nu nse jamfa molla ani mo jama dulal nse sisu wokono sakarantuma ni amira kuranda e ka fo gambia di smiling coast katun nga kairo long andung mbeteata nse nyim beteata ngante city nga covid-19 kele kantung abembe la jawya silala pour ka kuma seden soto nyin jankaro la kuola wala yamira nyin jankari la taman sir lebela ese 1025 kumandi